Okay, guys, welcome back. We are skipping 4-3 because I don't like the way it was set up, and we're going to go into all of those nonlinear functions chapter by chapter, okay? There will be specific chapters on each of the nonlinear functions. Today we're going to talk about how to graph just any general function, okay? In order to graph a function rule, you must remember that you are dealing with independent, that's the x, and dependent, that's the y, variables. Therefore, simply choose values for x, evaluate, and solve for y. Okay? You're going to make a table, basically. Now, bless you. Now, what happens is, since you have a linear function here, guys, you have the choice for choosing any x you want. This is not a real-world situation, so you're not talking about the number of donuts or the number of books or the number of people. If you were talking about a real-world situation, you cannot use negative values for x. But for this particular case, y equals negative 2x, first of all, a couple things we want to remind you about. We know that this is linear because the power of x is 1. Remember we talked about that yesterday, guys? Or the day before, rather? If the exponent of the variable is 1, then you know it's going to be linear. Okay? Does that make sense? Okay, now, let's make a table. X, Y. Now, what values do I choose for x? I like to use the Morrow 5. I call them the Morrow 5. And that's negative 2, negative 1, 0, 1, and 2. That's the Morrow 5. I'm going to use the Morrow 5 just about for every equation there is, except when there's a fraction. Let's say there's a fraction in front of the x, then I'm going to do something a little bit differently. I don't know if you guys remember from yesterday's homework review, but when you have a fraction as a coefficient, sorry, spelled that wrong, as a coefficient of x, comma, choose multiples of the denominator. And remember we talked about that yesterday, guys? Okay? So you're going to use multiples of the denominator when there's a fraction. But if there's no fractions, and remember the coefficient is this number right here, the number being multiplied to x. The number being multiplied in front of x. So if you don't have a fraction in front of x as a coefficient, you just use the Morrow 5. Excuse me. If you have a fraction in front of x as a coefficient, then you're going to use values of x that are multiples of the denominator. So here now it's just a matter of just plug and chug, man. When x is negative 2, what's y? 5. Very good. When x is negative 1? When x is 0? When x is 1? When x is 1, it's negative 1, buddy. And when x is 2? Negative 3. Everyone see what I just did there? I evaluated, right? Some of you look lost. Why? Why? Talk to me.
I just didn't know where those numbers were coming from. I know
You didn't know where the numbers were coming from? By now you don't know, my brother, that when x is negative 2, you evaluate and you plug it in, sir? Okay? So that's how it's going to be y equals 5. We are evaluating, guys. I cannot go back in time every lesson. You guys have to follow through. I'm sorry, but you have to. There's just no choice anymore. Okay? I do not have time to reteach everything every day. That is why we teach and you learn and you have homeworks. Thank you. Now we graph it. Excuse me. Negative 2, 5. Negative 2, 5. Negative 1, 3. 0, 1. 1, negative 1. 2, negative 3. And you're done. So that is how you would graph any function, pretty much. Later on, we're going to learn tricks. I'm going to show you a trick next chapter where you never have to make a table for this again. I'm going to show you tricks for quadratic functions where you don't have to make a table. And for cubic functions and absolute value functions and all the different types of functions, I'm going to show you tricks of the trade. However, we have to know how to just, right off the top of our head, graph something. And if they give you a function, they want you to graph it, and you don't know the tricks, that's fine. All you need to know is the shape of the graph, and you plug in the x values. We know that when x has a power of 1, it's a straight line, it's linear, correct? So we know that if we graph this, and you get something like this, you screwed up. We know that if you graph this, and you get this, you screwed up. That is the whole point of knowing the types of functions. A linear graph, a linear function, can only be a straight line. And remember yesterday we went over this. A linear function, you're going to see it one of three ways, and only one of three ways. Okay? You can have a linear function that has a positive slope, and that's going to be going up from left to right. We'll talk about slope later. You can have a linear function with a negative slope, which is going down from left to right. We'll talk about slope later. And you can have a linear function with a zero slope, which is a horizontal line, and we'll talk about how and why that works later. But these are the only three types of linear functions you can have. It's either going up from left to right, down from left to right, or horizontal. Now, some people may say, yeah, but you have this too, that's a straight line. But is that a function? No. Very good. You have different y's for the same x. So it's not a function. Okay? Does that make sense so far? Okay. Now, sorry, wrong. There's something at the bottom of this. My bad. My bad. I thought there was something at the bottom of this. Okay, let me see something here. Yeah, no, I guess I was wrong. Okay. Okay, let's try to check this out. The function rule W equals 146C plus 30,000 represents the total weight W in pounds of a concrete mixer truck that carries C cubic feet of concrete. What is a reasonable graph of the function rule given that capacity of the truck is about 200 square feet? Okay. So what's happening here, guys? First of all, what's the dependent variable and what's the independent variable here? That's the first one we got to figure out. Sir? No, 30,000 is a number. How can that be independent? What is the independent variable? No, the weight is not independent. Yes, sir. It's the C. It's the C, guys. Look, think about this, guys. You guys are giving me answers without even thinking. How can 30,000, first of all, 30,000 is not even a variable. So whoever said that, come on, think. Next, whoever said W, guys, doesn't W equal the events of this? So what can change here? I can either have C can equal 1, or C can equal 10, or C can equal 100. C is the independent variable. Didn't we talk about the fact that y equals mx plus b? Y, what it equals is the dependent. That is what's dependent. So the weight here is dependent on how many C cubic feet of concrete there is. Does that make sense, guys? Okay, so let's make a table. Now, can you use the moral 5 for this table? It's a real world situation, right? It's a real world situation. And what is the capacity? 200 feet, and actually it should be 200 cubic feet. Sorry. Okay, cubic feet. It should be cubic feet. That is the capacity of C. That is the max C that I can have. So, why don't we go by 50s? 0, 50, 100, 150, and 200, because 200 is my max. Why can I not go negative? Okay. If I have 0 cubic feet of concrete, how much does a truck weigh by itself? 30,000. Very good. See how the C is the independent? If there's no weight, then it's 30,000 pounds. If there's 50 cubic feet of concrete, okay, you have to go 50 times 146, all right, and then you have to add that to 30,000. So this is going to become 37,300. Bless you. When you have 100 cubic feet of concrete, 100 times 146 is 14,600 plus 30,000. You're talking about 44,600 feet. When C is 150, 150 times 146 plus the 30,000 is going to give me 51,900 pounds. And when C, the cubic feet of concrete, is 200 pounds, 200 times 146 plus 30,000 would give me 59,200 pounds. Okay? So it doesn't matter if we're working with little numbers or big numbers. You plug in the possible values of the independent variable, you evaluate it into the function, and you find the values of your dependent variable, which in this case is W. Now to graph this, you can graph this contained on one side, okay? Because it's only going to be the positive side. And the independent variable, the C in this case, the cubic feet of concrete, is going to be in the horizontal axis or the vertical axis? Yeah, the C, the independent. And the horizontal, okay? Horizontal. So we've got this the cubic feet of concrete here, okay? And we went 0, 50, 100, 150, 200. And then my W, I'm going to go by 10,000s. Okay, so 10, 20, 30, 40, 50, 60, and I'm going to put here W, this is weight, and then I'm going to put in thousands, okay, of pounds. Got to label my horizontal, and I got to label my vertical axis. Now, the truck weighs by itself 30,000 when there's 0 cubic feet of concrete in the truck. When there's 50 cubic feet, it's 37,300. In this particular case, you're going to have to do an estimate. So it's about here, roughly. At 100, it's 44,600. So about an estimate, it's about like right there. At 150 cubic feet, it's 51,900, so it's right over the 50,000, right over the 50,000. And then at 200,000 cubic feet, it's 59,200, which is like just right under. And there you go. Yes, you have to. Yes. Because, you know why? Can I have 51 pounds? Yeah. Can I have 51.2 pounds? Yes. So it's continuous. Every value of those are valid. Great question. Thank you, son. And we're going to talk today about what a continuous and a discrete graph is. I'm going to show you the difference, sir. Thank you, son. Does that make sense so far, boys? Okay. Easy peasy, Japanesey. All right. Now, let's talk about what my boy just asked. That must be so annoying in the middle of the video to hear those bells. I'm sorry. Continuous graph and a discrete graph. A continuous graph, guys, is a graph that is unbroken. A graph that is unbroken means that every value of x is valid. Let's go back for a second. My boy said, oh, we got to connect the dots. We create a line here. Yes. The reason I gave him is because here at 1, can I have 1 cubic foot? Can I have 1.2 cubic feet? Could I have 49.7 cubic feet? Can I have 55 cubic feet? Can I have 159.6 cubic feet? So all of these x's give me a valid y answer. So when all of the x's can have a valid answer, it's continuous. Sir?
In order to give you a C, you only put the dots, right?
No, I'm going to show you when you put the dots only. That's called a discrete. I'm going to get to that right now. Let's just focus on making sure we understand continuous. When we can use every value of the x, decimals, fractions, any part of it, because you can have part of a cubic foot, right? You can have half a cubic foot. You can have a third of a cubic foot. You can have 0.7 of a cubic foot. So those are all valid x's. So every single x is valid. So it's a continuous graph. Sir? No, you can't. Yeah, actually, yeah, you're right. You can't go over 200, so that would be my last spot. Thank you, my brother. Yes? Yeah, I would stop there because you can't go 200, past 200. Yes, sir. Okay, now, discrete. It's a graph that is composed of distinct isolated points. Let's say that I tell you every day at 8 in the morning, Mr. Morrow gets 2 cookies and he keeps them. I want to know the total number of cookies at the end of the week. Those would be individual points. Because if I'm saying every day at 8 in the morning, can I have half a day? No. So when I have to have exact values and I cannot have halves or decimals, that is what a discrete graph looks like. I want to give you now an example that's going to show you a discrete graph and a continuous all in the same problem, and hopefully that will wrap things up and show you when it's discrete and why, and when it's continuous and why. May I? I'm just gonna, did you get this top part though? Awesome. You got that, right? Okay. Okay, here we go. A local cheesemaker is making cheddar cheese to sell at a farmer's market. By the way, this is true, guys. It's not like I talked to a cheesemaker today, but this is real life. This is true story. When you're in a business, you don't just flip a coin and go, gee, I hope I make money. You don't close your eyes and go, oh, I hope I do, I hope I do, I hope I do. No. You actually create formulas. You create what's called a business model. You create a plan. And this person, they're not going to make cheese just to make cheese. They're going to make cheese so they can sell it, so they can make money. There is no business out there that creates a business to lose money. So you have to be able to create these formulas. Or you pay people like me to do it for you. You don't want to pay anyone to do it for you, right? You want to do it yourselves. So, let's go back. A local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make a cheese and the price at which he sells the cheese are shown. Write a function for each situation and fraff a function. I don't know what fraff a function is, but I do know what graph a function is. I don't know what fraff means, but graph, I know what that means. Is the graph continuous or discrete? Okay. Let's see if any of my boys can rise to the occasion here. What would the equation that relates 1 gallon of milk makes 16 ounces of cheddar cheese? How do you think we would write that equation? Vinson? No, not 1x plus 16, absolutely not. No, close. Guys, remember we're dealing with a dependent and an independent. Let's first, why don't we do this? Why don't we localize what the dependent and independent is? What is the dependent? No? Okay, guys, I'm not trying to be rude, but you're killing me. You guys keep telling me that numbers are the independent variable. A variable is a letter. So the 16 ounces cannot be the independent variable. So I'm sorry, with all due respect, wrong. Pay attention. I need the independent variable. Yes.
Milk.
The number of gallons of milk is very good, son. Milk is the independent. And we're going to go ahead and call that independent M. Very good. Because if I have 1 gallon of milk, I make 16 ounces of cheese, correct? But what if I add 10 gallons of milk? Then I make 160 ounces. Do you see how the number or the gallons of milk used are the independent? Because I could use 1 gallon or 57 million gallons. Are you with me, guys?
Yes, sir.
So what is the dependent variable? The amount of cheddar cheese. And we'll go ahead and call that C. So now, what's the formula? 16 ounces of cheddar cheese are made for every gallon.
1 M. 1 M. Oh wait, yeah, it's 1 M. 1 M
Or just M.
equals. I was gonna say 16 C.
That's exactly correct, brother. Give me some. Yes. Oh, I'm sorry. I don't know why I called it M. I called it W here. I guess for no. All right, for each wheel of cheddar. Yeah, okay. So instead of cheddar cheese, I called it W. So yes, every wheel of cheese, okay, equals 16 times the number of gallons used. Does that make sense, boys? Are you sure? Okay. Now, we'll make the table for that in a second. Over here, each wheel of cheese costs $9. First, what's the independent and what's the dependent? Thank you. The independent is the number of wheels of cheese that I buy. Very good. What is the dependent? The cost. Very good, guys. Very good. Because the cost depends on how many wheels of cheese you're going to buy. So what would the formula be here?
Are we gonna write the
Okay, what do you want to choose as the variable?
cheddar? It's W.
It's W. Good boy.
Cost is C.
C. Yes.
So
Good, Papa.
the it would be
He got it.
W equals oh no.
Come on, man.
No, I can't.
The cost is dependent, so it's phenomenal. And I don't, again, why am I choosing these crazy variables now? Money, I guess, but that was kind of stupid. I should have just, I'll leave it like this. Cost equals $9 times every wheel of cheese you buy. That makes sense, guys. This is the kind of stuff you're going to see in your midterm. Creating equations, choosing independent and dependent variables. Remember, guys, cost is always independent. Depends on what you buy. If they have a sale, whatever, for $5 CDs or DVDs or games or whatever, $5 for every game you in the store. Doesn't the cost depend on how many I buy? That equation would be C equals 5G, where G is the number of games that I buy. So if I buy 100 games, it's $500. Okay? Remember that, guys. There's always a dependent and there's always an independent. Now, let's graph these and let me show you which is discrete and which is continuous and why. Let's make a little table here. M is independent, W is dependent. Okay, if I add 0 gallons of milk, I make, if I have 0 gallons of milk, guys, if I have 0 gallons of milk, I make 0 wheels of cheese. I love how I got the answers. 9, 16. That was awesome. If I add 1 gallon of milk, I make 16 ounces of cheese. If I have 2 gallons of milk, okay, now, this is my question. Can I have 2.5 gallons of milk?
Yeah.
Of course you can. I can add 2.5 gallons of milk. 2.5 times 16 is going to be 40. Very good. So is this going to be a continuous or discrete graph? Continuous. And it would look something like this. Let's go by 8. 8, 16, 24, 32, 40, 48, 56, etc., etc. And then here we're going to go 1, 2, 3, 4. But you have this one point here at 2.5, which is valid. Because you can have a half a gallon. You can have a quarter of a gallon, a tenth of a gallon, a third of a gallon, a fifth of a gallon. So 0, 0, 0. 1 gallon gives me 16 ounces. 2 gallons gives me 32 ounces. 2.5 gallons gives me 40 ounces. Okay, this graph, it's not supposed to be curved. It is a straight line. I just didn't use graph paper, which, by the way, buy graph paper because for chapter 5, that's all we're going to use. Okay, it makes your life so much easier. So this is a continuous graph. Again, why? Because all values of x are valid. Does that make sense, boys? Now, let's go over here. C equals 9W. Okay, so we're going to make a little table where W is the number of wheels of cheese bought and C is the total cost for that. If I buy 0 wheels of cheese, I make $0. If I buy one wheel, 9, 2, 18. Can I buy 2.5 wheels? No. Guys, it comes in a whole wheel. And it's, no. Let's, hold on. Relax. Guys, they're selling whole wheels of cheese. They're not gonna start cutting it for you. It's not the way it works. It's already prepackaged. The guy made the cheese, put the whole wheel, put it in a plastic thing, sealed it airtight, put a little label on it, and he sells it for $9. Okay, think about it this way. Can you get a can of soup, cut it in half, and say, I just want half of it? No. Can you get a candy bar, cut it in half, and say, I just want half of it? Whoever said yeah, you're wrong. I'm sorry, with all due respect. You cannot do that. If you do, it's called stealing. So, okay, so you cannot have 2.5. You can only buy whole values of cheese, of wheels of cheese. So is this going to be continuous? It's going to be discrete. So let's go here, 1, 2, 3. Let's go here by 9, 9, 18, 27. So 0, 0, 1, 9, 2, 18, 3, 27. I cannot connect the dots here because I cannot buy an amount between 1 and 2. I cannot buy an amount between 0 and 1. I cannot buy an amount between 2 and 3. So that is a discrete graph. Do you guys understand the difference between continuous and discrete? Sir? Continuous is when all of the x values are valid. Discrete is when only individual values are valid. Thank you. Yes, sir. No, yeah, the one before we stopped at 200 because they said that there was a 200 cubic foot limit. Okay? Now, nonlinear functions, guys. Not all functions are going to be linear. Remember, we can use a vertical line test to see if it's a function. But remember, yesterday we learned how to test to see if it was a linear function. Remember, we test if it's a linear function if the change in y divided by the change in x is equal for all sets. But there are many types of functions, okay? Functions where x is raised to a different power other than 1 and or inside of absolute value symbols are non-linear. Linear is only when you have a power of 1. Linear is only when you have a power of 1. Linear is only when you have a power of 1. All right, there are a lot more functions than what I'm going to show you, but I'm just going to show you some basics. This, of course, what's the power of c here?
1.
So this is linear. What's the power of x here? So it's linear. Now, what's the power of x here in this third one? This is called quadratic. And trust me, we're going to get all into that later. But I just want you to know that when it's x squared, you're going to have a U-shaped graph. So if you're plugging in values into an x squared and you get a w, you're wrong. If you're plugging in values into an x squared and you get a straight line, you're wrong. If you plug in values into an x squared and you get a circle, you're wrong. The only type of shape you can have is a U. Sir? Yes, you can have an upside down U when it's negative, but we're not going to get into every single detail about these like I just finished saying until we get to the chapter. All I want you to do is to recognize what they look like so that if they ask you to graph one at this point in time and you don't have the skills to graph it without making a table, you at least know what the graph should look like, the general shape of the graph. When x is cubed, you're going to have this funky kind of like sideways S. When x is inside of an absolute value, remember how we said absolute value has two sides? Yeah, positive and negative. Well, you're going to have a V, not a U, but a V. And if you have a x in a radical, x cubed is called cubic. Absolute value is called absolute value. Okay, absolute value. And this one, when it's in a radical, it's called a square root function. You don't have to know anything about these except for the general shape of them. So that when you are plugging in values into stuff with these notations, okay, you're actually knowing what the end result's going to look like. If I have a squared, I'm going to have a U. If I have a cube, I'm going to have this funky looking S. If I have an absolute value, it's a V. If I have a square root, it's kind of like half of a U. It's the only thing you need to know right now. You're going to learn how to manipulate and work with all of these by the end of the year. But right now, I just need you to memorize the shape that is going to come out of these. Now, why is that important to know the shape, Mr. Morrow? Because I'm going to ask you something like this. Graph y equals absolute value of x minus 4. Right off the bat, what shape do you know you're looking for? A V. So let's go ahead, guys. What values are we going to use? There's no fraction. The moral 5, negative 2, negative 1, 0, 1, and 2. All right, guys, let's do this. For those of you who don't have the skills yet in your head, absolute value of negative 2. Okay, what's the absolute value of negative 2? Minus 4. Done. What's the absolute value of negative 1? Minus 4. Done. When x is 0? When x is 0, the answer is not 0. Oh, the absolute value of 0 is 0. Yeah, 0 minus 4. Boom. When x is 1, what's the absolute value of 1? Minus 4. When x is 2, what's the absolute value of 2? 2 minus 4? Negative 2. All right. Negative 2, 2. Negative 2, negative 2, sorry. Negative 1, negative 3. 0, negative 4. 1, negative 3. 2, negative 2. Do I have my V shape? That's the only reason why I showed you those functions. I promise you, I will go through all of those functions one by one in their own chapters. I promise you. All you have to learn for now is the general shape to look for. You knew this was an absolute value. You knew it had to give you a V shape. If you screwed up accidentally and you had a graph, I'll do it in green. If you had a graph like this, start over. You screwed up.
That's the one for...
If that's the cubic. If you have a U, you screwed up. Start over. If you just have a straight line, you screwed up. Start over. If you have just half a U, you screwed up. Start over. This can only be a V shape and only a V shape, sir.
Arrows?
Yes. Because it keeps going on forever. Yes. And it's continuous because every point can be used. What did I give you? Y equals x squared plus 1. What kind of a shape are we looking for? A U. Very good. So we have x, y. We're going to use the moral 5 because there's no fractions in front of the x. So negative 2, negative 1, 0, 1, and 2. Okay, when x is 2, what's negative 2 squared? Very good, because remember, the negative 2 is being squared itself. 4 plus 1? All right, when x is negative 1, what's the answer? Come on, guys. What's negative 1 squared? What's 1 plus 1? When x is 0, what's y? When x is 1, what's y? When x is 2, what's y? Now, let's graph that sucker. Okay? No, this is not a v. It's a square, so it's going to be a u. Negative 2, 5. 1, 2, 3, 4. Negative 1, 2. 0, 1. Come on, Moro. 0, 1. 1, 2. And 2, 5. Notice that's a U. People are going to be tempted to do a V. It's not, you're going to be off. It's wrong. Don't do a V because this is not a V shape. This is a U shape. Does that make sense, my brothers? Okay. Let me see. I think we're done. Oh, wait. No. One more. What if I have x cubed plus 1? What kind of a shape am I looking for? It's that little squiggly ass, that little sideways ass. What values of x am I going to use since I have no fractions in front of the moral 5? Negative 2, negative 1, 0, 1, and 2. Okay, now, pay attention to this, guys. This is where our skills come in. Negative 2 cubed plus 1. What's negative 2 cubed? Negative 8 plus 1? Awesome. What's negative 1 cubed? Negative 1 plus 1. Okay, when x is 0, what's y? When x is 1, what's y? No. 1 cubed is 1. 1 plus 1 is 2. When x is 2, what's y? 9. 2 cubed is 8 plus 1 is 9. Now, we graph it. I don't appreciate that you're packing up yet. I'm not done. Negative 2, negative 7. It's right here. Negative 1, 0. 0, 1. 1, 2. And 2, 9. So look, it looks weird. It looks weird to any untrained eye. But you know that it's going to have this shape. So you're golden. You got to know those general function shapes. Give you a little heads up. We got quiz on Tuesday on 4-4. We learned 4-5 Tuesday, 4-6 Wednesday, 4-7 Thursday. Friday we review. Monday we take the test. And then depending on how you behave, we can start the midterm review or we just continue teaching. When the bell rings, you are dismissed. Thank you for a great class. May God bless you all.